Solving systems of linear equations through elimination. There are a number of ways that you can solve systems of linear equations. We've talked about graphing and we've talked about substitution. We're now going to talk about elimination. So go ahead and write down this system of linear equations. Pause the video and write it down. So let's think about elimination. What does elimination mean? It means to get rid of something. So when you solve a system of linear equations through elimination, essentially what you're trying to do is eliminate one of your variables so that you can solve for the other variable and then plug it back in. So what is it that I mean? Well, first of all, we could solve this system by graphing. We could graph each of these lines and find the point of intersection. We could also pretty easily solve this because we already have a single x here, and we could just subtract 3y from each side and then substitute that back in. But what I am going to choose to do is eliminate one of my variables. So the easiest thing to do is to look for one of your variables that doesn't have a coefficient in front of it. So I'm going to focus on this x right here. So what I'm going to do is I'm going to run a -3 through this entire equation so that I can eliminate my x's. So I'm going to go ahead and say -3x, and then a -3 times a +3y is a -9y, and then a -3 times 7 is a -21. So I now, I haven't changed the value of anything because I ran the -3 through the entire equation. So now I'm going to go ahead and rewrite the first equation underneath it. And elimination allows me to add my equations together, and essentially that means combine my like terms and then solve for y. So what happens when I add these together is that my -3x and my +3x zero out. So I'm left with -9y and a +2y, and that is a -7y. And so -7y is equivalent to, or has the same value as, -21, and +14 is a -7. So I'm going to solve for y by dividing by 7 on both sides, and I get that y has a value of, oh, that's a -7. Y has a value of +1. Now all I have to do is pick one of my equations, my original equations. I'm going to pick one of those, and I'm going to substitute y in and solve for x. So I'm going to go ahead and go to a new page, and I'm just going to choose the first equation just to make it easier. I'm going to choose the first equation and plug in my y = 1 and solve for x. So I'm going to go ahead and substitute in, and I'm going to say that 3x plus 2 times, we think that y is 1, and that balances with 14. So 3x plus 2 equals 14. So we add 2 negatives, or subtract 2 to both sides. So 3x balances with 12, divide by 3, and we get that x is 4. So that means that we think that the solution to this set of equations is 4 and 1. Now, it is never okay to just stop there. You always want to take your solution. So we're going to take 4, 1, and then we're going to substitute it back into our original equations to make sure that this solution works for both equations. Okay, so I rewrote my equations, and I have the solution that I think is correct, which would be 4, 1. So now we just have to test to make sure that that's the correct solution. So 3 times my x has a value of 4, plus 2 times 1 equals 14. So 12 and 2 balances with 14. And yes, 14 does balance out with 14. So the point 4, 1 does satisfy the first equation. So let's test the second equation. Instead of x, I'm going to go ahead and put in 4 plus 3 times my y, which is 1, is 7. So 4 and 3, so 7 balances out with 7. So yes, my other point is, or my other line is satisfied. So the solution to this system of equations is 4, 1. All right, so I'd like you to write down this next set of equations and go ahead and solve using elimination, and then we will check together. There are a number of ways that you may have approached this, but I think that the most straightforward way would be to focus in on the y's, because you already have a -9 as the coefficient for both of those. So it's really easy to go ahead and run a positive or another negative through to make one of those a positive 9y. So what I'm going to choose to do is just take my top equation. You can use either one and go ahead and run a negative through. So that becomes a 2x plus 9y equals a positive 25. Then I'm going to write my next equation underneath it, and it doesn't matter which equation you have on the top and which you have on the bottom, because all you're doing is combining like terms. So then we're going to go ahead and combine. So 2x and 4x is a negative 2x. Those zeroed out, and that has the same weight as 2. So we're going to divide by -2 on both sides. So, by -2. So x has a value of -1. Now to solve for y, all I've got to do is take my value for x and substitute it back into one of the equations. And again, it doesn't matter which equation you choose. So I'm going to go ahead and do the top equation. So -2 times, instead of x, I'm going to say -1 minus 9y equals -25. So that's positive 2, minus 9y is a -25. So I have to subtract 2 or add 2 negatives to both sides. So -9y is equal to -27. Divide by -9, divide by -9. So I'm going to go ahead and write it over here. I think of that my y has a value of, a negative divided by a negative. That's going to be a positive 3. So we think that the solution to this equation, or to this system of equations, is -1, 3. Now, am I done yet? No, because you always want to go back and substitute so that you can verify that your answer is correct. Okay, so again, I think that my solution is -1, 3, so I rewrote both of my equations and I just put them next to each other. So let's test it out. -2 times -1 minus 9 times 3 is -25. So that's 2 minus 27 is -25, and 2 minus 27 is -25, and that balances with -25. So yes, the solution worked for this equation. So let's test it out over here. So that's -4 times -1 minus 9 times 3, and does that balance with -23? So that's a 4 minus 27 is -23. So 4 positives and 27 negatives is -23, and that does balance with -23. So since this point satisfied both equations, then yes, it is our solution to the system.